We're going to use this today. We're going to go on into today's lesson. Today's lesson is sum and difference for sine and cosine. When you're doing sum and difference, you have to be very careful because you would assume that all you do is just add the two angles together to find their cosine, but that's not true. If we look at our unit circle and we think about here, we have cosine of 30 degrees plus 60 degrees. Well, what's 30 degrees plus 60 degrees? 90. So that gives you 90 degrees. Well, look at your unit circle. What's the cosine of 90 degrees? That's a radians value.
0, 1?
What's
0, 1?
cosine? Thank you.
0.
Your cosine, remember, cosine is x. Sine is y. Okay, cosine of 30. Unit circle, what is it?
Cosine of 30, unit circle, 0, 3. It'll be top square root of 2.
What's the cosine of 60?
60 will be top square.
Stop saying pi, those are your radians.
1/2.
Okay? Is 0 equal to square root of 2 plus 1/2? No. That's not an equivalent statement. Okay? That is not an equivalent statement. 0, the only thing 0 is equal to is itself. So therefore, this is not an equivalent statement. That's why you just can't add the two angles together to find that value. Okay? So what we do have is formulas that make it possible to add them together. So the first formula is if you have the sine of A and the sine of B, then you can solve for what you need to solve for. So if I have sine of angle A plus angle B, what that's going to give me, in order to solve it, it's going to become, I call it sac plus cos. Sac plus cos. The B is the silent. And the reason why is because sine A, cosine B, cosine A, sine B may be a lot for your brain to memorize at one time. But if you can make a trigger or a way for you to memorize it, then go with it. I had a friend who remembered it as SC plus CS. I like words, so I would say sac and cos. So notice here that sine, if you're adding, then your operation is still adding. If you're subtracting, your operation is still subtracting. So it will be sac minus cos.
You do the opposite.
Okay? You're subtracting. Subtraction.
Oh, you don't.
Subtraction. Okay? And again, if she just said SC minus CS. And she said anyone knows that A comes before B, so she said she didn't need the CS, the A and the B. All right, but however, when you get the cosine, notice that their signs are opposite. So if I'm adding over here, I'm going to end up subtracting. If I'm subtracting, I'm going to end up adding.
That's because cosine's inverted. Is it because cosine's inverted?
Huh?
Is the reason why it's opposite because cosine's inverted?
Yes. Okay, so again, for me, it was cac minus sas and cac plus sas. Okay? So cac and sas are cosine to me. So when I remember sine is sac and cas, cos is cac and sas. So however you're going to memorize it or choose not to memorize it, but the reason why we had to memorize things is because we didn't have open note and note card tests. We actually had to memorize all formulas. So that formula chart you had, I just had to know them. I wasn't given the option to make a note card. I had to actually study and memorize all 25 functions and identities on that paper. So, you guys should be grateful. All right, there are steps that you do when you have the problem. So step 1 is you identify A and B. So step 1 is you identify A and B. So at this problem, what's my A? A is the angle. It's not the trig, it's the angle. 3 what?
X.
And B is?
2x.
Step 1. Step 2 is identify the pattern. So is it a CAC-SAS or a SAC-CAS? That's
It's a CAC-SAS.
It's the first one.
It's the
it's a CACB plus a SAS. Right? So because it's that means that my rule that I'm following is cosine of A minus B. And then step 3 is you plug it and simplify.
How will you be able to determine which one it will be?
Yeah.
Hold on. Can you repeat that for me?
Like, how do you
know which one you're going to use? One of those?
What it tells me, it says I have a cosine of A, a cosine of B, cosine of A, cosine of B. It tells me I have a sine of A and a sine of, so sine of A, sine of B, and which one does that match? What is it equivalent to? The last one.
Do we need calculators?
Your test is non-calculator. All right, so plug in and simplify. So now I can plug in. So I have cosine of, and what's A?
3x.
And what's B?
2x.
And what's 3 minus 2? So your answer is? Cosine X. 3 steps. 3 simple steps. Joey, are you ready to add numbers to this? Take out the variable and add a number. I said Joey. Yes. That helps you identify what rule you're using. That's it. It's right here. Sine A and sine B. It helps you identify the rule you're using.
Oh, that's an acronym.
All right. So let's look at 3. We're going to follow the steps. Step 1 tells me to do what?
identify A and B?
What's A?
Yeah, A is 105 degrees.
And B is?
15 degrees.
Okay. Step 2 tells me to do what?
Identify the pattern.
Identify.
So I have sine of A times cosine of B, cosine of A times cosine of B. So which rule is that?
It's gonna be the first one with the second one.
It's the
It's the
second one.
second one.
Yeah, that's
So
what
that's sine of A minus
B equals.
down our pattern. Step 3 is what?
Wait, it is?
What's A?
105 degrees.
B? Simplify that too. And what's the sine of 90?
Oh.
1.
Huh?
Somebody put like sign of 90.
No, you use your unit circle. You won't have a calculator on your test. That's why we're learning. Oh, that's a problem.
I still made 85
On the second step right there, which one is that like sec B minus
Sine of A, cosine of B, cosine of A, sine of B.
See, this is cosine of B.
Oh, I switched it. I did. What are you talking about?
Second step says sine of A, cosine of B minus cosine of A, cosine of B.
Oh, my S.
Oh.
That. My bad. I'm saying it, but not. I didn't write it. Is that what you're saying, Don?
Yeah.
Thank you, sir. Don, you said something that actually made sense. So proud of you. I knew you could do it all along.
I mean, I did this whole time.
All right, here we go. So we're going to get a little harder. Do we feel comfortable with that?
I feel comfortable with it.
Okay, we're going to get a little harder. All right, I'm still angry that someone stole my Pop-Tart. P.S. So
We are too.
you just might as well spread the word.
I was late, so it wasn't me.
I didn't know you had pasta. I just the whole door closed, remember?
Okay, just want to point that out. All right, notice that we have alpha and theta. Okay, this is a lowercase alpha and this is a theta symbol. Okay, now if you do not like alpha and theta, change them to A and B. No need to freak out because it's written in Greek. And then it's just that most mathematicians around the world use Greek letters because it's more worldly known than American language. It's older than our language. And math is older than America, so therefore they use what was used before. Exactly.
They use those
Huh? Exactly. And we made our lives difficult with the customary? Yes, exactly. We just made our life difficult. All right, so we identify what information is given to us. So they told us that our sine of A equals 4/5, and our sine of B equals. But do we know what our cosines are?
No.
No. So we do not know the cosine of A, and we do not know the cosine of B. But is there something that we've learned that relates sine and cosine to one another so that if we know one, we can solve for the other one that's missing? What is that? It's an equation. It's an identity. So where should I look at? On my identity chart. So if I look at my identity chart, it tells me that if the basic 8 that we went over, which one tells me if I know sine, I can solve for cosine?
Ratio.
That involves tangent. That involves cosecant. It's a what? All right, so now let's look at our Pythagoreans. One of these Pythagoreans involves sine and cosine. It's the first one. So we can actually use the Pythagorean identity to help us solve for cosine. Because we know sine, so then we just have to solve for cosine. And at this point, are we all comfortable with squaring numbers and subtracting them from 1? I would like to believe so. What's 2 squared?
4.
What's 1 minus 4?
3.
Yay, you're capable. You did it. That's what we're about to do. Okay?
Oh, you heard him?
No.
He's high, what you call it, high-sided? That man over there.
Now you know I'm talking about my
He
nigga.
stole
I
the
said it
Pop-Tart.
loud.
He stole the Pop-Tart, then he's high-sided.
Hmm.
Snitch. Call me officer.
So,
Are you done?
here we go. So we're going to do A and then we'll do B. So to find A, we know that the identity is sine squared of A, because we're talking about angle A, right? Plus cosine squared of A equals what?
Hold on, you got me. Where you get the prescription?
Pythagorean identity.
Oh, yeah, my bad.
I just rewrote it on this page.
Oh, so doing the
All right. So once you've identified the Pythagorean identity, now you're going to substitute in what you know. So I'm going to substitute in what I know. The only thing I know is sine of,
Hey.
and what is sine of A?
4 or 5.
4 5. 4 5.
Okay, is cosine of A by itself yet? I haven't done anything.
I'm just trying to write down. Okay.
Oh, so if we replace the sign and could just put 4 over 5.
We subtract 4 over 5.
Huh?
Replace it to put 4 over 5.
I substituted it. That's why I said I'm going to substitute it. Because sine of A is 4 over 5. Now, I don't know how many of you guys remember when there's a square on the outside, you're going to distribute to the numerator and the denominator. So you have 16
Over
25 plus cosine squared A equals 1. What am I going to do to move? I heard it. I'm going to subtract.
You gotta do it from both sides.
Okay? If I have a whole pie and my pie is cut into 25 slices and I eat 16 of those slices, how much of my pie do I have left? 9. There you go. I have 9 left. This 1 represents the whole pie. Okay? Out of that whole pie, I'm going to eat 16. The 25 represents how many slices are in my pie. So I'm going to eat 16 of, which leaves me with? 9. There we go. Okay? Now, if you cannot see that, I will do the math over here. So following to this side. If I have 1 minus 16 over 25, before I can do anything to these, they have to have a common denominator. So 1 over 1 can become 25 over 25. And what's 25 minus 16? 9. That is what I mean when I say you have a whole pie and you eat 16 slices of it. That leaves you with 9 slices. Got it? You agree? Okay. All right, so, oh, my laptop's down. Is the thing open? All right, so now I have squared. What's the opposite of squaring something, Pete? The opposite of squaring something is to find its square root. So, what you do to one side, you have to do to the other. So I can take the square root of cosine squared. When it's a fraction, you're taking the square root of the numerator and the denominator. So cosine of A is okay, at your table, you guys are going to do cosine of B. So at your table, work on finding cosine of B. It's going to be the same process, except instead of starting off with, no, instead of starting off with sine squared A, it's going to say sine squared B. And plug in what you, all right, going to give you a couple moments to do that. Parent functions. Oh no. Pause it.